Hey everybody, it's Jason Allen here, the concrete pipe guy, technical resource engineer for Oldcastle Infrastructure in the Mountain West region. I've been getting a lot of questions lately about gasketed box culvert. This is a relatively new product to our line of products here in Oldcastle in Utah. And I decided today for our Oldcastle Academy webinar that it would be a good idea to do a case study on a gasketed box culvert project that we did a couple of years ago for the Davis and Weber Counties Canal Company on SR 193 in Layton, Utah. So with that, let's go ahead and jump right in and talk about the project. So as I mentioned before, this was done for the Davis and Weber Counties Canal Company. This project was done in the winter of 2021 to 2022, so just a couple of years ago, and it was a really great project. And I want to talk a little bit about the process of going through kind of from planning stages into design and then into construction on this project for us. So this is an overview map that shows the canal itself. So if you look at the big yellow arrow there, this is the little location that we were kind of focused on in there. But this is the whole big area of where we're at. Notice that airfield there, that is the Hill Air Force Base. So if that will help you orient yourself a little bit on where we're at. So right there on the kind of the southwest corner of Hill Air Force Base, right by the base housing, is where a lot of this was being done. So this is zoomed in of where that yellow arrow was and where we're going to be focusing on. If you notice, there are three different distinct sections on there by colors. You've got the purple section at the top on the north there. You've then got kind of that middle teal section, and then there's a red section as well. So this was done in three different sections. Those houses that you see to the north of that line, that's all the base housing there. So we're with the right of way, as you can see where this goes. This is the existing canal, and you can see there's some really interesting things that we had to deal with. Not only being right next to the Hill Air Force Base, there were trails, roadways going under major UDOT roads. So it was a lot of utility concerns. Really interesting thing there. So some of the owner concerns is we started talking with the design engineer and the owners about what they were trying to accomplish on this project. We learned a lot of really cool things about it. So number one, this is old infrastructure from the 1930s and the 1960s is when this canal was built. Okay, what they were seeing was huge water losses on this project. And one of the big reasons was because it's an open channel. And so during the hot summer months here in Utah, it can get well over 100 degrees here in northern Utah. And so you were seeing a lot of evaporation. We were losing a lot of water through evaporation. But in addition, some of these were concrete lined, but there were sections of dirt lined channel. And if you know anything about dirt lined channels, sometimes if there's a really good clay layer under it, it can hold water really well. Other times, if that clay layer isn't as watertight as it could be, or if it gets if the clay cracks or some water gets through there and it washes out some of the clay, there are a lot of things that can happen where dirt lined channels can lose a lot of water by percolating down into the groundwater. And so these were big concerns for the canal company that they were losing so much water. Another big thing that a lot of times we don't really think about is the algae growth and algae blooms in our reservoirs from this water. And the reason this was a concern is because where it was open channel and in the summer months, as that sun and heat is beating down on the water, it warms up and increases the temperature of the water. And as the water temperature increases, that also increases the likelihood of algae blooms and algae growth in our reservoirs. And this was a big problem and a big concern that the canal company had, that they wanted to protect against that. So as the owner was looking at some of these things, the designer was talking about it, they knew that they needed to have watertight joints to protect against the water losses. And so they looked at mastic and joint sealant as one option. And as they looked at that mastic and joint sealant, we know that mastic is a soil tight joint, not a watertight joint. So there's going to need to be some additional sealant or treatment to these joints to make sure that they are watertight. Now, one of the concerns with that is not only does it take more man hours to install that joint sealant, but if they're not applied correctly, if there's issues with the sealant, it may not last the whole life of the box culvert. And so that's a big concern, that you would have to go in and reapply this years down the road to keep it watertight. So we also looked at rubber gasketed joints. Now, as I mentioned, this is a relatively new product to our market here, and Oldcastle has been making these for a number of years. But this was the first time that Davis and Weber Canal companies had looked at using these rubber gasketed box culverts. And so the rubber gasketed box culvert, they are watertight, and they would meet those requirements for water losses and protecting that water from loss. So another issue was the alignment. As I mentioned, there were a lot of different things that we were working at with trails and trail crossings, high pressure gas lines, utilities, roadways, existing bridges, different things. And because of the existing alignment, uh, these box culverts would have to be curved a little bit. And so we used bevels on some sections because we could just bevel the ends of our box culvert so that we could get the curvature right, so that we could keep it in the existing canal. And in some more severe cases, we used bends or custom structures to curve this box around existing structures and keep it in the existing canal. As I mentioned before, there was a lot of utilities that we were working with. One in particular was a high pressure gas line that they had to go under on the northern part of the project, and that was a major concern. Another one was the right of way. We wanted to keep this as close to the existing canal as possible so that the project engineer didn't have to go out and do additional right of way acquisition. Because this was being done when there was no water in the canal, which is in Utah, typically the winter months, weather is always going to be a concern. So, you know, freezing, frost, snow, rain, there was a lot of weather concerns that we had to work around. And that's one thing that we always have to keep in mind when we're planning these canal projects in the winter is what do we anticipate the weather is going to look like? And even our best anticipations are not always accurate. So we got to keep that in mind. Another issue is because this is out west, it's far enough away from the benches and that we were running into some groundwater issues that we had to keep in mind and take into account on dewatering if necessary and different things there. So as we talk about mastic joints, I mentioned before that these are soil tight joints. And so when we install the mastic on a joint, we put a small portion, as you can see, just a little overlap of maybe 6 to 12 inches on the bottom of the groove or the box culvert that will be receiving the tongue of that. So we sometimes call them bell and spigot. So this would be kind of the bell end or the groove end. And then on the other box that's coming into it, we put the rest of the remainder of the mastic with a little bit of an overlap, about a ½ inch overlap on the top and sides of the tongue or the spigot end of the gasket. So when we're preparing these boxes to put the mastic on, a couple of things you need to keep in mind is they have to be very clean, the joints, or the mastic won't stick. We don't want any dirt or sand or anything sticking to that. So we want it to stick directly to the concrete. So we've got to clean that off. Additionally, we want these to be dry. So this was a canal project that we did for a canal company up in Logan Canyon years ago. This was one that we did in the winter. And when we're dealing with winter, obviously weather is a concern, as we mentioned before. And these boxes would get wet at night with either rain or snow. And so we'd clear them off. And what he's doing with his blowtorch is actually drying. It doesn't need to warm up for the mastic to stick. We have cold weather mastic, but he was drying this with the blowtorch there to dry the concrete so that the mastic could stick. So once it's clean and dry, we can now apply the mastic. So we roll it out, use a rubber mallet to apply it with a little bit of force so that it'll stick to the box culvert. So this is on that groove part or the bell end of that box culvert that they want to put just about a 12-inch up the sides on those. And then the remainder of the mastic goes on the top of the tongue or the spigot end, and then again applying with a rubber mallet so that we can get it to stick. And then you notice it goes all the way down the side so that there's just a little bit of an overlap. So as you can see, as it comes in, you can see the overlap of that mastic on the tongue end of there. As it comes into the groove, it matches up just right. And so there's just about a ½ inch of overlap on those as it comes in. So we started looking at the gasketed joints for these using rubber gaskets. And these are rubber gaskets that are very similar to what we use in reinforced concrete pipe. And this is the specification that we introduced the design engineers to. It's ASTM C1677, the standard specification for joints for concrete box using rubber gaskets. Now, one of the big questions that we get asked is how much hydrostatic pressure can these gaskets withstand? So this is a performance-based spec that talks about the joints and what they need to be tested to. And so these are the tests that we do and what we look at to make sure that we are meeting this performance-based specs. Now, on the left-hand side of the screen here, you see 9.1.1 boxes in straight alignment. When the boxes are laid straight, we want to make sure that these can be subjected to a hydrostatic pressure of 5 psi for 10 minutes. That's the testing requirement. Now, full disclosure, we have tested higher than that, but this is the minimum that we're required to test to make sure that these gaskets work. So we put two boxes together and we test those and we make sure that it can withstand 5 psi for 10 minutes. So that's what we do on straight alignment. Now, on the right-hand side, if you notice 9.1.2, this is boxes in maximum deflected position. So you are allowed to deflect these boxes slightly, right? So that if you need to shift and move them a little bit on the alignment, you can deflect those just a little bit. And when you do that, you can still maintain some of your pressure in there and it's still watertight. However, when you deflect those, these ones are tested at maximum deflection point at a hydrostatic pressure of 3 psi for 10 minutes. Deflected to create a position 1/2 inch wider than the assembled position on one side of the outside perimeter of the joint. So that's what we test when we say maximum deflected position is you're deflecting at a 1/2 inch there. So anything beyond that, if we need to move and shift, you would have to use bevels or elbows or something. So as we looked at this, we compared the gasket and the mastic. Okay. So the gaskets are installed in the plant while mastic is installed in the field. Because they're installed in the plant, the gaskets are installed in a more controlled environment while mastic is going to be subject to field conditions, like I mentioned before, with dirt and silt getting in the boxes, having to clean those off or having them be wet. So we'd have to dry them off. So it's subject to the field conditions there. They're not weather dependent for the gaskets because we're installing them inside in a controlled environment. And mastic is subject to the weather concerns of whether you're using warm or cold weather mastic, whether it's dry enough to install it. For the gasket, there's less people required in the field because we're installing them in the plant and delivering them to the site. For the mastic, it is requiring more people in the field. You don't really need to take any of the time to install the gaskets because we've already taken it, and mastic takes time. The gasket would provide a watertight joint, but for mastic to get a watertight joint, you would need that additional sealant. And so it does take a little bit more time. Now, one of the things that we were looking at was, well, what about cost? Interestingly enough, the gaskets themselves cost almost the same as the mastic. So when you add the sealant in, it's actually, with the time it takes to install that sealant, in some cases it can be more expensive, depending on the contractor, more expensive to do mastic and sealant. But generally, we say it's about the same cost as gasket and mastic and sealant are going to be about the same cost. So as they looked at all of these things, it was really a no-brainer for the design engineer to choose the gasketed joints for this project. So one thing that we did on this project that was really helpful was they staged all of these boxes right next to the canal in the order they were going to go and the locations that they were going to be. This is not always possible on every project, but in this project it was, and so we took advantage of that. And when we deliver these to the site, we want to make sure that these boxes are not sitting directly on the dirt. Now, if you have a good clear area of a concrete pad or a roadway or something that's clear, that's been swept off and cleaned, it may be okay to set those directly on like a trail or a road or a parking lot or something. But in most cases, when we think of construction, we're thinking, we're just going to be setting it right on the soil. And so when we do that, we want to ensure that there are some wood. You can see the wood inside these boxes. That's the dunnage that they would set so that the box culverts could set on that dunnage so that they're raised up off of the ground a little bit. The problem that we run into is if you get any dirt inside that joint, right? Those gaskets aren't going to be able to seal as well because they get dirt in it. And the most common way that we get dirt in those joints is when we set the boxes directly on the soil so that dirt sticks to the bottom of the box, it sticks into the joint, it gets up into there. And so that's a pretty big problem. Now, this is a picture of a pre-lubricated gasket. These are the type of gaskets we use, so there's no lubrication necessary. These are the components of this is you have the actual gasket itself, which is what's labeled as the deformation section with the lamels, and that is what creates that seal in that joint. You also have a rolling tube, and inside that rolling tube, on the right-hand side, you can see as it's cut, you can see the cross-section there. In that rolling tube, that is where the lubrication is inside there. And then you've also got those little teeth inside there that as this gets homed into the box culvert, as the tongue comes into the groove section, that rolling tube will just roll over the top of the actual meat of the gasket there. And as it rolls in and helps guide it into there, those teeth, that lubrication rolls over the top of it, and those teeth will kind of lock into place once it's in there. And it deforms and compacts that section. So those two little holes, those little lamels, will compress and create that watertight joint for our gasket there. All right, so that's the kind of the overview on gasketed joints and how they work. But let's talk a little bit more about the project here, and we're going to focus first on this southern phase. There's the two sections that I showed you before. One was that teal color, one was the red. This is the first section of the project that we're going to focus on, because there were two different project sections done by two different contractors. So this first section was done by Whitaker Construction. This was done in 2021. So we started work on it in 2020, started manufacturing the boxes and putting those through. The box size was a 7-foot by 6-foot box culvert. And we also used gasketed joints on this, obviously, as we mentioned before. There were some miscellaneous structures that they had to work around, like a screening structure and tying into some bridges and some different things. On this one, in order to meet the curves, we used bevels. So we had 1-inch and 6-inch bevels on our box culverts. There were 355 pieces, and the lay lengths on these were 8 foot long. So that was roughly 2,840 feet, plus or minus. And the total job cost was $1.36 million, and the project engineer was JUB. So as we looked at this, these are the plan sheets of what they were doing. So let's look at first, let's kind of start on that top section there, that north section. And let's talk about that. This was as we tied into SR 193, you can see the road on the right-hand side. That's SR 193. And there was an existing bridge structure there that we were tying into. And so this is the cast in place portion that they did a closure pour. As they set that first box, they laid it there and then they tied in. Now, the other contractor on the northern most piece was Bowen Construction. And Bowen Construction was going to be pouring all of these cast in place sections anyways, and these closure pours on their part. So they came in and did all of the closure pours for Whitaker as well. So they were hired to team up with them and do all of these cast in place pours. So this is instead of ripping up SR 193, because the box was already in great condition, they just doweled in some rebar and tied into it and set a cast in place pour to connect these boxes there in that section. So it worked out really, really well. So these are the details of our bevels. This is the 6-inch bevels, as you can see on that. Kind of maybe focus on the top left-hand side there. You can see that it bevels. The header is beveled 6 inches. So we just have different headers for these box culverts that we use to get that bevel so that we can get those angles around. There were left and right bevels in 6 inches, and also 1-inch left and right bevels. So these were the details in our plans that we submitted as our shop drawings to get these approved for our bevels there. Again, still gasketed, so they would work just fine. So we're good on those. Okay, so as we look at this, there was a minor issue as we got started with our layout. When we laid it out, the bevels that we laid out and the way we wanted it done was that we would have to cut the corner of the canal. And as we got started on the project, Whitaker said, no, we want to lay this within the canal. It's going to be so much easier because the canal's already there. Just the staging, it's going to work out. And so instead of using our layout, we had to shift and change the bevel configuration slightly so that we could lay this completely inside the canal. And so that's the benefit of having, structural engineers and drafters that we have on site at Oldcastle, that we can work with the contractors and work with the design engineers and get these layouts just right so that we know which boxes need to go where, and we can deliver them correctly in the right order so that they're getting set correctly. So this was a good thing that we could catch early on and make that adjustment. So as we look to the north, this is the staging of the project. I did mention before that they were staging these boxes right next to the canal. It made it so much more convenient than what we usually see in other projects. Now, sometimes we don't have this luxury of being able to stage it right next to where it's going to be. And so this was one that they definitely took advantage of that and made it work really well. This is in the big turn as they're coming in. There's a roundabout there that they were coming into and some other things that they were concerned about coming in. So this is that curve. You could see the bevels doing their job to curve that around out of the bridge. This is the bridge on that portion as they're coming into it. It's an existing bridge. What they decided to do on this, it was kind of unique. Instead of just tying into the bridge, what they did was they just demoed the bridge deck and then set the box culverts inside the concrete canal bottom there and just use that as the existing bedding and made it work. So here you could still see the walls, the wing walls and the bridge walls inside of where the bridge crossing was. So they just took out the deck, set the box culverts, and then backfilled around it. You notice also here's the utility line that they had to work around. So I mentioned before we did have some utility concerns, but this was one that was pretty easy where we didn't need the full width of the bridge. They just demoed the bridge deck, put the boxes in, and backfilled as necessary. So as they came out of the bridge, we start heading towards, you could see the sound wall there. That's I-15 as you come out. So this is coming out of the bridge and bending and curving again around I-15. And this was as they came into the north, the northernmost part of their project, of the Whitaker part, was coming into a Quanda screen structure. And so they set the boxes there, and this is the cast in place portion of the wing walls for that screen structure. And this is what it looked like when they finally did all the pours and all of that. So this is a way that they could put a screen up and catch any debris and go in there and clean it out. So it's a really cool little structure that they had to do to tie those boxes into. So that was the kind of that teal portion there in the middle. That's what that section was. Let's look now at the red section down at the bottom, because this was also part of Whitaker's part. This is down by, if you notice that big white building, that's what used to be the old Taipan Trading Company there, just off of SR 193. And so this one was being replaced. It wasn't an open channel. This was an old corrugated metal pipe. And what happened was this old corrugated metal pipe over time had squashed and was starting to collapse in some sections. And so this was a major safety concern. It was affecting the flow of the water, how much water was getting through there, because the geometry was no longer what it was when it was first installed and what it was designed for. So this is a picture of them removing that old corrugated metal pipe, that squashed corrugated metal pipe. And this is that area there behind Taipan Trading Company looking to the east. Again, good place to stage it. As you notice, there's a trail on the side. So they just laid it directly on, they swept out the trail and laid these boxes directly on the trail. This is looking northwest behind Taipan. On the right, or on the left-hand side, is the before picture. And on the right-hand side is the after picture of that same location and how it turned out. And it just ended up being just a great project there. It turned out beautifully. So this is as they tied into SR 193. Again, they had to come into that existing bridge or that existing box culvert. So they did a cast in place pour again, and Bowen did that for Whitaker as well. Now, let's look at the Bowen construction portion. That was that northernmost portion, that purple section that we had looked at. For this one, this was done completed in 2022. The box size was 7 foot by 8 foot box culvert. These were gasketed joints again. On this one, we had 3 fabricated elbow bends because there were some turns that were too sharp that we couldn't get done with the bevels based on the existing canal and trying to set these boxes in those canals. So we had to fabricate elbow bends. This one had 125 pieces at 8 foot lay lengths, and it was about 1,000 feet total, plus or minus. The job cost on this was $543,000, and again, JUB was the engineer. So as I mentioned, this was that purple section up to the north. As we look at this, as we zoom in a little bit more, you can see just on that top northernmost portion there, you could see that really sharp bend around there. That's where we had to use these elbow bends. These were the details that we did for those elbow bends. A lot of times when we cast these elbow bends, we'll take two sections of box culvert, and we'll cut them while they're still green before they've cured. We'll expose the steel. We'll tie new steel into that, and we'll do a little closure pour around it to the angle that we need it to be. It's a really cool process. Um, we we would it's not as easy to do. It's a little bit more costly, but if we can get it done with bends, we would prefer to do that. But or with bevels, I should say, we prefer to do that. But if we need to, we always have this option of doing bevel or elbow bends as well to supplement the bevels so that we can meet the curves that we need to. So while they were doing this, Bowen Construction was actually concurrently and simultaneously laying a ductile iron water line as well. So they had the trench for the box culverts, and then they had another trench that they were doing a water line as well. So they just did that simultaneously. It was a pretty cool deal for that. So this is them installing that box along that frontage road as they're coming in. Here's a picture looking north along there on that frontage road, and then on the left-hand side it's looking north, and on the right-hand side it's that same location finished, just looking to the south. So turned out great, looks awesome. You can't even tell that there's a box culvert under there. They did a great job doing that. They also had on the north end, as they came around that bend with that elbow bend and those bevels, they moved it around there. They had a trail crossing, so similar to what they did with the bridge. They did the same thing where they removed the bridge deck, like they did on the roadway. They removed the bridge deck for the trail and then laid the box culvert inside the canal, inside that, and then backfilled around it. Now, that's pretty difficult in its own right to do that. But the other issue was, as they got moving, there was also a high pressure gas line that they had to set these boxes underneath it. And so if you've ever worked around setting culverts or pipe under a high pressure gas line, it is very nerve-wracking. It is very dangerous. And so there was a lot of prep work that had to go into this to make sure this was done just right. And it went off without a hitch. So everything worked out really, really well. At the end of this box, they tied it into that existing crossing under I-15 you can see there, and everything went really smooth. So some of the lessons learned on this project were that contractors were hesitant at first with the gasketed box culvert. They'd never used it before. They didn't really know what to expect and how to handle it, and so there was some hesitation and some concerns as we got going on this project. So what we decided to do as Oldcastle is we increased some of the front end training for these contractors for this new product, and so helping them understand and bringing them into the plant and showing them how these things were installed and done. It really helped them get these things installed quickly. The contractors actually, both of them that we talked to, they said we prefer this. Once they got going, they said we prefer these gasketed box culverts. It's quicker, it's much easier. We don't have to worry about applying the mastic, and it saves us time. So once they got going, they realized, wow, this is a much simpler way of installing box culvert. Another lesson learned is that good leveling course is critical to get that good joint closure. So if you want that joint closure so that we can make sure that we're getting that watertight seal and that watertight joint, we need to make sure that we have a good leveling course. We also use pulling inserts and come-alongs for this to home them in, and that's a must to get these things homed as much as we need them to create that watertight seal. And then if you have a good crane operator, that is always a huge benefit. If you have someone who knows what they're doing with a crane and can get these things placed in, a good crane operator is always a plus. So I mentioned the leveling course. This is an example of a big box culvert that we did years ago on I-15. This was a 24 by 6.5 foot box culvert. But as you notice, they're using kind of a sandy gravel there and screeding it with a board to make sure that we can get it nice and level to receive these box culverts. This is the level of care that is necessary to really get these good joints. And if you take a little bit of extra time getting a good leveling course, it just makes such a huge difference in installing these boxes. I also mentioned come-alongs and pulling inserts. We will cast these pulling inserts directly into the boxes on the inside, on either side of the boxes, and then you would just attach a come-along, and then two folks can get in those boxes and crank that come-along and home it and tighten it as necessary while it's being supported by the crane, and the weight of the box itself is still elevated by the crane, and then they just home it in. So here's a video of two guys using these pulling inserts and come-alongs. And notice that if one gets a little bit out of, off center and off alignment, you can pause on one side and then just crank on the other side to home it in. And so these are just an absolute game changer on getting these boxes homed and making it easy. So this is a video of that box culvert getting homed in, and as it comes in, and you can kind of see that gasketed box culvert on there as it comes in. So notice as they're homing this in, you've got that gasket in place there. The box is still elevated, right? It's still lifted, and all the weight is held on the crane. So as they home it in there, now as that tongue end goes into that groove, that rolling tube will now roll over the top of that gasket and create that watertight seal. And once they get it into this position, they can connect their come-alongs into the pulling inserts on the end of the new box and start homing that in and pulling that tight to get that joint. So great system that worked out really well, and we were really happy with the way this project turned out. It was very successful for being the first project that these two contractors had used the gasketed box culvert. We were really happy with how they did and how it turned out, and it just ended up being just an absolutely beautiful project at the end there. So well done. Hats off to both Whitaker and Bowen Construction. They did an incredible job. Hats off to JUB engineers for designing this, and for Davis and Weber Canal companies for being so progressive and forward thinking and trying to find a solution to their water loss problem and selecting these gasketed box culverts. So thank you for taking the time to learn about this gasketed box culvert project. For more information about gasketed box culverts or any Oldcastle products, email me at jason.allen@oldcastle.com or visit oldcastle.com.